Good afternoon, everybody. Thank you for joining the webinar on MeshGuard wireless gas detection and wireless best practices. My name is Stephen Tsao. I'm your webinar moderator for the day. Any feedback or comments for the webinar is greatly appreciated. Joining us today are expert speakers Jan Banducci, Global Product Manager for Fixed and Wireless Detection Technology, and Praveen Sharma, Global Product Manager for ProRay Guardian. They will be giving us an inside look to the best practices of gas detection. Before I turn it over to the expert speakers, let me show you how to submit your comments and questions. In order to provide your feedback or ask a question during the live show, please email us at events@raysystems.com or at our Twitter handle, #RaySystems. We will try to answer as many questions as possible during the live session. Any unanswered questions will be compiled, and we will get back to you with a response. This webinar is scheduled for 60 minutes. Please feel free to type in your comments anytime during the show, and we will answer them at the end. So at this moment in time, I would like to introduce you to Jan Banducci, Global Product Manager, to start us off.
All right. Thank you, Stephen. Appreciate it. Okay. Again, thank you, everybody, for joining us, those of you in the room and those of you that are joining us via the web. Today, as Stephen mentioned, we're going to be talking about best practices for oil and gas detection. Best practices for gas detection in the oil and gas industry. So briefly, what we're going to talk about, or do a little bit about what Ray Systems is. A lot of you aren't familiar with us as a company. We'll do a quick overview. We're going to talk about exactly what user problems we're trying to solve with our wireless systems. We'll talk a little bit about a wireless system overview, some benefits of wireless systems, and then we're going to do a brief cost analysis of a wireless system versus a fixed system. And then I'm going to hand it over to Praveen, and he's going to talk about the ProRay Guardian software, which is the centralized hub where all of our data is routed through. Okay. So who is Ray Systems? So Ray Systems was founded in 1991. We're headquarters is in San Jose, California, which is where I am today, along with all the folks in the room. We have 20 years of experience. We're a $100 million plus company. We serve mainly 5 key markets: energy, which is what we're talking about today, oil and gas exploration, hazardous materials management, industrial safety, civil defense, and then also environmental. So where are we? As I mentioned, we are in San Jose, California. That's our global headquarters for the company. We also have our European offices that operate out of Copenhagen, Denmark. We have Asia-Pacific sales and marketing in Beijing. And then we have a factory with engineering and manufacturing in Shanghai, China. Okay, so what does Ray Systems do? Who are we and what do we do? So we make gas detection. So 500,000, 500,000 gas detectors units have shipped since 2002. We produce our own sensors. Over 15,000 sensors ship every month. We have 20 patents on chemical and radiation sensors, including PIDs, LELs, lots of technology that we're focused on. And then global intrinsic safety certifications. You saw all of our global offices. We sell into most of the regions of the world. Each of them have their own safety certification requirements. We are globally certified for almost all of our products. And then we're a leader in wireless sensor network technology. We've been supplying wireless gas detectors for the better part of the last decade. We're going to talk a lot about today some of the newer systems that are available, some of the benefits, really expand on what we do in terms of wireless gas detection. Okay. So who are our customers is a very small sampling that I could fit on one slide. You can see we've got lots of multinational companies specific today to oil and gas. We've got BP, Shell, Total, a slew of other large multinational corporations that use our gas detection equipment, both in oil and gas and the other industries that we mentioned. Okay, so on to wireless gas detection for oil and gas exploration. So really what we're trying to do is solve customers' problems. So what we're trying to do here is for fixed gas detection, typically a system is heavy, has bulky cables, is difficult to maintain and install. So these pictures should look familiar to some of you folks that are in the oil and gas industry, specifically in exploration. As you know, that Fixed gas detection has been around for a long time. We, as a company, also produce fixed gas detection systems. So we're not trying to say that one wireless is better than fixed. They certainly both have their own usage scenarios. However, what we're trying to do in oil and gas exploration, we see there's a lot of opportunity, a lot of benefits to using wireless systems over fixed systems. So we're going to try and focus in on that today. And the problem that we're solving is these bulky systems that are difficult to maintain and install. So what is our proposed solution? So really what we're talking about is wireless gas detectors. And the gas detectors are there to address safety and compliance issues for the oil and gas exploration industry. So as you can see, just a quick example here. An example is our MeshGuard system, where we use portable gas detectors deployed. Not only can the detectors talk to each other, but they all report their information back to a centralized controller, which is storing all of that data and is using it and displaying all that information in real time back at a centralized location. So what does the wireless do for you in oil and gas industry, oil and gas exploration? So really what we're talking about is the versatility on a rig. So up on the screen now you can see that there's a kind of a general layout of a rig. What the wireless system does, it provides you the maximum versatility on this rig. So for example, you can use LEL monitors and H2S heads at the cellar, right where the drilling is taking place. Oftentimes people are using LEL and H2S at the shale shaker. They're also using SO2 at the flare pit. In addition, with our system, you can use H2S on the fence line to monitor the footprint. So any of the gases that are of concern that are leaving the actual pad area that need to be monitored, those can be done with a quick fence line application with wireless products. And then the real beauty of our system is that you can add and subtract other monitors as needed. So back at the offices or down in the additional by the water pits, it's really easy to add and remove detectors and move them around as necessary. For example, on this fence line over here on the side, if the wind is blowing in that direction, you can quickly establish that fence line. However, the following day, the wind may be blowing a different direction. It literally takes a few minutes to walk out there, grab the detector, move it to a new location. The wireless mesh networks reconfigures those radios in near real time, in fractions of a second. So when you move radios around, you move detection points around, it's all very seamless to the end user. Everything is quickly reestablished and very flexible on the rig. Okay. So wireless systems are typically are a turnkey system solution. You really want them to be compact, lightweight, and easily transportable. That's really the major benefit of having a wireless system. So as you can see in our example here, in this Pelican case, you have 8 detectors and a controller. All can be deployed by a single person in less than 30 minutes. So that 30-minute deployment time is really a key asset when you're talking about oil and gas exploration. So as the rigs move around from location to location, or as conditions change on that rig, these systems can easily be moved, easily be deployed, and it doesn't really even require any specialized training. You simply take the detectors out of the box, turn them on, the radios are smart enough to self-configure, all that data gets reported back to that controller. So literally within 30 minutes you can deploy or redeploy a system, and you really don't need any specialized training. Again, they provide continuous detection and data transmission for up to 6 months at a time, so on a single battery. One of the things we want to talk about is why is this new to the industry? Why aren't other people doing this? And really it has to do with the technology. In the last 5 to 10 years, with advancements in low power radios, advancements in the low power sensors, advancements in battery technology has really allowed us to create devices that can still meet your safety and compliance needs, but also have the ability to last for 6 months at a time with continuous power and data transmission. And then again, as I just mentioned, these wireless detectors, there is no compromise when it comes to the safety aspect of them. All of our wireless gas detectors are certified Class 1, Division 1 for intrinsic safety here in North America. Internationally, we have ATEX and IECX Zone 0 certification. So if you're moving from a fixed head, a traditional fixed head, to a wireless system, there is no compromise on the safety. You have the exact same certification levels for hazardous areas that you would on a fixed system. Okay, so a quick example of wireless gas detection in oil and gas. So you can kind of see the setup here. You have wireless gas detectors that are deployed out in the oil fields. You have sensors that can detect flammable gases and toxic gases. You can also see we have some other powering options in addition to the internal battery that lasts for 6 months. You can go even longer than that with the use of external batteries or with the use of solar systems, solar pack. You can see that all of those detectors are relaying their information back to a centralized controller in real time. So you can see on the screen that that data is transmitted back to that controller. At the controller, you have relays inside of there, so you can send out larger range alerts or alarm notifications. So you can trigger lights, horns, sirens, even process controls, turn on and off fans, turn on and off processes in your, for the equipment, all based on the level of safety that's being shown to you in real time via the detectors. And then finally, what Praveen's going to talk about after I'm done talking about the hardware is this piece where the data, once it's on that centralized location, on that centralized controller, it's very useful to the people that are on that site, but it may be even more useful to have that data on a network where remote people can log in with a PC, and they can view all that data in real time. All that data is being logged, all those alerts are being sent, all that information is being all sent in real time to remote locations. So for example, you could have somebody in Houston area that wants to view data from drilling operations in North Dakota, or somebody in the Middle East that's doing a drilling operation, and somebody in England that wants to view that data. So all of that is enabled all in real time, all out of the box with wireless systems and the software component that Praveen's going to talk about in more detail at the end here. Okay, so again, wireless versus fixed systems, and again, it's not really a competition. It's what we're really trying to say is that fixed systems have always had their place in the industry, and we agree that there are some fantastic applications for fixed. Fixed systems aren't going anywhere. Us as a company also produce fixed systems as well. What we're trying to say is that in certain applications, specifically oil and gas exploration for this agenda of this topic, a wireless system makes a lot of sense. There's a lot of benefits to doing wireless systems in oil and gas exploration. Okay, so why wireless? Just kind of the quick rundown of some of the advantages and disadvantages of wireless versus fixed systems. So on fixed systems, as we mentioned, there's definitely some clear advantages when you're talking about fixed systems. And one of those is that you have the runtime. So because it's not battery powered, you have a continuous source of power. There's no issues with the continuous runtime of those units. You can run almost indefinitely in terms of power. The other advantage you have on a fixed system is that if you're willing to run that cabling, you can run almost infinite distances. So we put 5,000 feet on the chart, 1,500 meters. We know you can go a lot further than that depending on how your system is configured. So really, in terms of transmission distance, you don't have any limitations. However, on the wireless side, you do have a lot of other advantages, namely some of the ones we've already talked about, but in terms of the space requirements. You saw the picture before. Most wireless systems that we produce are all able to fit inside a single case. So that can fit on the back of a pickup truck, and can go in the trunk of somebody's car. The entire system fits in a box. Whereas when you're looking at a fixed system, you've got hundreds of meters or hundreds of yards of cabling, of conduit. Fixed heads are typically fairly heavy. So it's really a bulky, heavy system that's not easy to be moved. Again, you have the power requirements. Wireless gas detectors are battery powered. And then we talked again a little bit about the portability. Especially in oil and gas exploration, we know that the rigs move around frequently. So if you want to install a fixed system, you can, but then when you want to move it to the next the next drilling location, you got to pack up that system, make sure everything's safe, redeploy it at the next location, which can take anywhere from a few hours to a few days when you're talking about a fixed system. With a wireless system, you literally take the detectors off the wall, put them in the box, bring them to the new location, turn them back on, and you're ready to go again. It's literally a minutes versus hours or days. Okay, continuing on a little bit more about the reliability and the maintenance. So when a detector goes down on a fixed head system, you typically have to have somebody go out there and address that issue. So it's either an electrician or it's somebody that's familiar with how you wire up a fixed system. You've got to go out there, stop your operation, have the system checked out, troubleshot, look at the detector, possibly replace it, and then start your system back up again. With a wireless system, because the network is easily reconfigured all in real time, you can simply take the bad detector off the wall and put a new one out there, and it's seamless to the end user. So it's literally, again, it's minutes of operation versus a few hours of downtime. We also talk about the installation complexity. We touched on it before, but with a wireless system, you really don't need any specialized training to do it, right? You take it out of the box, you hit the power button, and you put it on the wall. With a fixed system, you typically, like I said, you need an electrician or a technician to go out and wire things up and make sure that they're doing it in accordance with the safety regulations in your particular area. And then finally, we're going to talk a little bit more about the costs in a few slides. But when you're talking about installation with a wireless system, you can literally do it in minutes. And then when you're talking about a fixed detection system, at the minimum, it's hours, and most likely probably a few days to install a fixed gas detection system. Okay. So, like I said, we're going to talk a little bit more about the installation system cost. So there's a lot of numbers on these slides, and I don't want people to get bogged down in the numbers, so we're going to kind of go through it a little bit slowly, and I think you'll see the end results, regardless of the numbers that we're going to look at in detail. You'll see that they all come out to be about the same. So we'll get to it in a little bit, but a lot of times when you're talking about an installed system cost, that key word there is installed, right? So when you're talking about equipment cost, typically we see a lot of end users in oil and gas. They say, okay, I need a gas detection system, bring me a bid, right? So I'm going to go look at a couple vendors. So some guy shows up with a, proposal 1, this is a fixed system, and then here's proposal 2, here's a wireless system. And on the surface, when you start to look at the numbers, a wireless system on the equipment costs, the costs are just higher, right? So we've used some prices, some list prices that we use for our wireless systems. Other people have wireless systems as well. These are our prices, and on the fixed system, we just use some kind of generic numbers that are typical of what we would see in a deployment here in North America. Again, for the folks who are joining us internationally from overseas via the web, these numbers I know are different in different regions, but like I said, you're going to see at the end result of this, you can put in any numbers you want here, and the results are roughly the same. So we'll get to that a little bit. So in any case, at the first glance, it looks like, okay, our fixed system for a 10-point example, 10 heads, is roughly $6,500 on just the equipment costs. And the example we're using, again, 10 heads on wireless is $22,000. So initial glance at the two bids, you're saying, well, one's significantly less expensive than the other. Right? So again, the key word is installed system cost. So in addition to those equipment costs, what you're going to have are additional materials costs. So with a wireless system, there are no additional materials costs. Everything's wireless, right? They're battery powered, and the signal is sent via wireless. So on a fixed head system, you have things that wiring costs and conduit costs. So for the purposes of this example, again, we're using 10 heads, and we're making the assumption that all the heads are roughly 500 feet away from the controller. So again, these are numbers that we're using that what we'd find here in North America in terms of the cost of the wiring and the cost of the safety conduit. So again, these numbers can change depending on which region you're in. I would encourage you to put in your own numbers here, and I think you'll get the same results that we're about to show you. So additional materials costs, now there's 0 for the wireless, and there's an additional $10,000 in additional materials for the fixed system. So okay, in addition to the additional materials costs, in addition to the materials cost, you have installation labor costs. So the actual act of installing all of those cabling and all that conduit costs actual time and actual money for that labor. So we have a comparison. We're saying it's roughly 12 minutes per head for a wireless system. That's the time to walk out 500 feet, put a detector out there, then come back. You also have a fixed head. We're saying it's 20 minutes. Where the real difference is when you're running cabling and conduit, that takes time to run that type of stuff. So we have some estimates in here of how long it takes to install cabling and how long it takes to install conduit. And you can see that on the wireless system, we're looking at roughly $200 to install for labor costs. And then on the fixed system, you're looking at a value of $38,000. Right? So it's some very real time, very real money that it takes to install a fixed system. And then finally, in addition to those labor costs, there are battery replacement costs. So on the fixed side, 0. Right? We have that centralized source of power. There's no additional power requirements. On the wireless side, you do need to replace batteries. So in our estimates here, we've taken into account, we're saying it's going to last for 5 years. How many batteries you need it to last for 5 years? Every battery lasts 6 months. We've also taken into account how long does it take to swap a battery, to do the actual labor. So all that's calculated in, and on a wireless system, you need about $3,500 in terms of batteries and the labor cost to keep those batteries at capacity. So, and again, on the fixed system, you're at zero. So the net, when you're all done adding up the total installed system cost, where we're at is that the grand total for a wireless system for 10 points is roughly $26,000. Right? And the grand total for a fixed system is roughly $55,000 installed. Right? So now when that same end user is looking at the two quotes, they're saying, okay, this one looks really cheap, it's a fixed system, and this one looks relatively expensive, the wireless one. What you really should be looking at is a total installed system cost, and it's significantly more cost savings on the wireless side than there is on the fixed head side. Okay, so just another quick way of looking at that same exact example. The 10 points of gas detection, $55,000 was the fixed head cost. So the way to look at it is, for a traditional fixed head system, you have this initial equipment cost is typically what an end user looks at. 12% is the percentage of the overall system cost. You have this additional materials cost. This was the cabling and the conduit. And then you have this, you've got this big chunk here at the top. It's 70% is the installation labor cost. Right, so you've got a big piece of labor on there. So when you compare that traditional fixed system example to a wireless system, you'll see on the wireless system you've got this big chunk on the bottom, which is the equipment cost, which is this 41%. You've got zero additional materials. You don't need any extra cabling or conduit because it's wireless. You've got a small percentage for battery replacement costs, around roughly 6%. You've got this very minuscule, less than 1% for the installation labor cost. So at the end of the day, when you're looking at a total installed system cost, roughly 53% savings for a wireless system versus a fixed system. Right? So I think, as I mentioned before, I know that the numbers we use, there's a lot of assumptions of values in that example we were just looking at. So I would encourage you to put in your own numbers and do your own calculation for the region of the world you're in, your labor costs, your materials costs. We've done it for all the different regions that we sell into, right? So the example we used today was North America. I've done the same exact calculations for Middle East, for the North, for Scandinavia, for South America, for all these different regions. And the numbers always come out to be roughly the same. There's always a cost savings here. It may be down to something 15, 20%, but it actually can get even higher. It goes 30, 40, 50. Even some regions are at 60 to 70% savings based on your labor costs. So again, the example we're showing here is North America. I would encourage you to put your own numbers in. I think you'll find that the same results. There's still significant savings to be had, regardless of what region you're in, for wireless systems in oil and gas exploration. Okay. So the other thing we need to talk about when you're talking about costs is this downtime. So anybody who works in the oil and gas industry and the exploration knows that downtime equals money. Right? So when your rig goes down, you're not producing anything, and that costs you real money. So downtime is really the enemy of the oil and gas exploration industry. You don't want the system to go down. So when you take into account a wireless safety system versus a fixed head safety system, there's some very other cost savings that should be taken into account. So from our customer base, we've talked to a lot of people that say when a rig goes down, it can lose anywhere between $5,000 to $50,000 per hour. Right? So that's the cost of a rig being down. So for our example, we took a number in the middle. We took $20,000 as per hour. That's how much it cost that rig to be down. So when you're talking about replacement of detectors, so detectors go bad for whatever reason. They get hit by a truck. Folks who've been on an oil rig know that folks who work out there aren't the most gentle with any of the equipment that's out there. Things happen. Things break all the time. So when you're talking about a fixed head detector, if that thing breaks or it goes down, again, you need to have somebody that knows how to fix it come out there. So it's typically an electrician or it's a technician. They've got to shut down the system, remove a bunch of conduit, remove some cabling, replace that detector, wire it back up again, make sure it's calibrated on the controller. There's a bunch of processes that need to take place in order to get that fixed head back up and going. And so we estimate anywhere from 2 to 48 hours depending on who's on the rig at the time when the detector goes down. If somebody knows how to do it, then that may be a few hours. But if they need to call in a remote person that has to drive from miles and miles or kilometers and kilometers away, that could take some serious time for that person to get out there and fix that issue. So a rig down for 4 hours is $80,000. With a wireless system, a detector goes down, all you do is you go grab another detector from the box, turn it on and put it out there, and take the bad one and bring it back inside. Right? So there's really no replacement downtime. It just takes as long as it takes you to walk to go get a new detector and replace the old one. The beauty of the mesh network with the radios is that when a detector drops out, it's really easy to add another one. The radios reconfigure in a fraction of a second to make sure that they're all talking together, make sure all of that information is being relayed back to the controller. Okay, similar with a sensor replacement, people who work in the gas detection industry are familiar with gas detection. Sensors go bad, either from just they have a limited shelf life, limited usable life, and they could also be poisoned. They can be hit with different chemicals. A lot of different things can happen to a sensor. So with gas detectors, you have to replace sensors periodically. And so it's the same thing when you're replacing a sensor on a gas detector, it takes some time. So you have to shut down, typically that's that detector, you put the new sensor on, you need to calibrate it, then you bring it back up to speed. So that takes a few hours. So on a rig, again, that downtime is really costly. So on a fixed system, you're looking at something around 2 hours, and that's roughly $40,000 using the estimates. So again, it's the same exact scenario for a wireless system. If the sensor goes bad on a detector, you go grab another detector from inside, you power it on, you bring it out to the location, and you take the old one with a bad sensor and bring it back inside. Everything self-configures itself. So it's really a few minutes to replace or sensor on a bad wireless detector. And again, finally, it's the same thing with calibration, the same thing I just mentioned. Typically on a fixed system, you have to calibrate the detectors just like you would on a portable system. And that calibration, typically, when you're calibrating an instrument, that means it's not measuring. So you'd have to shut down your system, or you have to do it during some downtime to calibrate that monitor. It's not a very long process on a fixed head, but it's still something, right? So even if you're down for half an hour while you're calibrating, your 10, 15, 20 detectors, it's going to take you some time to calibrate those. And then during that time, it's costing you money. So these numbers, as you can see, we're using the example here of $20,000 per hour, but when you compare these to the cost of an overall system, these numbers are much, much larger. So this downtime is actually more important than the cost of the actual equipment itself. Right? So we already showed that there's definitely some cost savings on just the installed system costs, but the real savings come in the downtime. And that's really enabled by the flexibility and the versatility of a wireless system on a rig. So there's less downtime. There's certainly less downtime with a wireless system than with a fixed system. And that downtime equates to very real dollars in the oil and gas exploration industry. Okay, so I think this is my last slide. This is just kind of the quick overall summary of wireless systems. So again, you have a complete system in a box that can be deployed in less than 30 minutes. That's really the benefit of wireless, that versatility, the ability to configure, reconfigure, deploy, redeploy systems, all within less than an hour. So you've got continuous detection and transmission for months at a time on a single battery. So that's the new technology we're talking about, the low-powered radios, low-powered sensors. All of this stuff has come together for the gas detection industry and allow us to make detectors that will go for 6 months plus at a time. So again, there's no compromise on the safety certifications as well. So we have global safety certifications. There's no trade-off on a fixed system versus a wireless system. We have Class 1 Division 1 certification for North America, and we have ATEX Zone 0 and IECX Zone 0 as well for international overseas locations. They're exact same safety level as any fixed head you could buy. No specialized training required for deployment. The radios are smart enough when you turn them on. All of that data is being aggregated by the radios and eventually back to the controller. And then finally, there's a significant cost savings versus fixed systems, which we talked about at length, primarily due to the low installation costs and the reduced system downtime. So with that, I'm going to turn it back over to Stephen. Hopefully this was informative for you, and Praveen is going to talk in a little bit.
Thank you for that, Jan. And Jan will be joining us back on stage again at the end of the webinar so he can answer questions from you guys. So speaking of questions, before I turn it over to Praveen, just a reminder to submit your questions to our email address box at events@raysystems.com or at our Twitter handle, #RaySystems. I wanted to also note that today's session will be recorded and archived on our website in a couple of weeks or so. So now I'm going to turn it over to Praveen Sharma, our Global Product Manager for ProRay Guardian, to join us and continue the discussion.
All right. Thanks for the quick introduction, Stephen. I appreciate that. Good afternoon, everyone. My name is Praveen Sharma, and I'm the Global Software Product Manager. So obviously, I'm going to talk about the software component of the overall wireless gas detection system, which we are talking today. So what I'm going to do is, since Jan has already introduced us with the wireless gas detection system, I'm going to use one of his slides to start my presentation so that you can visualize what component in the system I'm going to talk about. I mean, this is the same slide. I hope you still remember it from Jan's presentation. It is showing a typical deployment of wireless gas detection system in a RIGS environment. There are sensors out there. They're collecting data, sending it to the controller. And if you have connectivity, internet connectivity or local area network connectivity, then you can push that data to ProRay Guardian. And this is the piece which I'm going to talk about. And once the data is available in ProRay Guardian, then there you can share this data anywhere in the world with the experts for various different reasons. And that is where it provides a lot of value. And in my presentation, that is what I'm going to talk about. So here is a quick agenda. We're going to talk about what is ProRay Guardian, what kind of value it brings, who is the target users for this product, and how it helps them. Then we'll also look at one application example, just to give you an idea how this product can be used and what kind of value it can provide. Then we'll look at PRG wireless safety system. Again, another view of the overall system, just to show you what are the different bits and pieces of the system. And then we'll summarize it, the overall system. So what is ProRay Guardian? Now, ProRay Guardian is primarily, it's a command and control center, which is primarily used for proactively monitoring and sharing real-time data with remote experts so that they can provide their opinions and make some critical decisions. In other words, the decision makers, they don't need to be in the hot zone or near the hot zone. The information can be available on their fingertips while they're sitting in some safe zone, or which can be maybe 1,000 miles away from the hot zone. And as you can see, the data is collected. It is sent to the central location. And also, you don't have to, like traditionally when you have sensors, you don't have to now look at the sensors data. Oh, sorry, on the devices. The data is coming to you. You don't have to manually download data. It is available for you, coming in real time. From a different perspective, if you look at it, what this tool does, it takes the data, different kind of data, whether it's a sensor data or the location data, converts it into information, shares it with the remote experts. And when remote experts look at the data, combine their experience with that information, that results into knowledge, and which helps in real, like a good decision making. So at the end of the day, it is a tool which helps in decision making or making the right decision at right time. So before we go and talk further about the product feature, let's talk about what are the challenges, what we face on day-to-day basis as safety managers or industrial hygienist or as a first responder. Now, the first and foremost challenge is always for us is if there is a situation developing, we want to know about it quickly. And if it has already developed, we want to know, hey, how bad is the situation? Is it bad enough that it requires some evacuation? If answer is yes, which area I need to evacuate first? Which area I can go after that? How can I inform my other team members, the rescue teams, to coordinate my rescue efforts? So these are very typical challenges which we go through in our day-to-day life as safety managers. And the good news is the tools like ProRay Guardian, the wireless gas detection system, are designed to address those kind of challenges. And we have an easy solution for that, and that is what we are going to talk further. So now let's look at how products like ProRay Guardian, they address these challenges. First, as you might have guessed it by now, this is the tool for individuals and teams who are responsible for the safety of people and properties. What it provides in terms of capabilities, the tool provides real-time remote monitoring and modeling capabilities. Using modeling techniques, you can figure out how big is the threat, where the threat is heading, so that you can plan accordingly. You get remote alarms. You don't have to be near the hot zone. Real-time data sharing. As we were talking earlier, if you have your experts sitting in a remote location, you can share that data with them and get their opinions. Threat location. There are some features in the product which can tell you where exactly is the threat and where it is heading. So all these features, all these capabilities, when you combine them, that enable early detection of the situation and, of course, the faster responses. It also helps in increased situational awareness because everything becomes available quickly on your fingertips. It helps in collaborating with the responders. So if you have rescue teams, you can coordinate your efforts with them. Threat verification and quantification. I mean, this is always one of the challenges. When you have a threat situation, you want to know how big is the threat. First, you want to know whether it's a real threat or not. Once you find out that, then you want to know how big is the threat. And that is where this tool can help you. And then, again, dealing with your team members for responding to the situation. But at the end of all this, it helps in saving lives and assets. So if you combine all these enablements, it results into saving lives and assets. Now let's look at some specific industrial roles and how they get benefited by products like ProRay Guardian. Here's one example, like safety managers. The features in tool, it helps them implementing their procedures, the safety procedures in their work environment. It helps them putting some control for health hazards. And of course, stay compliant, because the tool has some features where they can produce reports on day-to-day basis and share it with the compliance agencies. Then we have industrial hygienist. Again, similarly, it helps them assessing the potential risk in their work environment, interpret sample results, develop strategies, look at historical data, find out, okay, what they need to do to protect their future, assess worker exposures, and again, stay compliant. First responders, this tool helps in creating a situational awareness. They will know, okay, where the threat is, how can they basically strategize their response. So now let's look at an application example. And this is a good example of data sharing. We call it like centralized remote monitoring. As you can see on the slide, there are regional offices, and regional offices have their own product monitoring going on. They are monitoring their local sites. And at the same time, what they can do, they can share the same real-time data, what they are looking locally, with their corporate office, which can be 1,000 miles away. So for compliance reasons, for safety reasons, data sharing is the key. And that is what this tool provides. Now, let's come back and look at the overall wireless safety system, maybe from 100,000 feet height, because there's no technical jargon here. It's a simple picture, simple diagram. As you can see, at the center, there's a ProRay Guardian running on a laptop, on a ruggedized laptop in this case. And it is receiving data from a variety of wireless devices here. Now, these wireless devices, they can be handheld devices like multi-ray, mini-ray, or they can be portable devices like area array, weather pack, or they can be devices which you can wear on your body. The responders can wear on their body like bio harness. And all these devices, they are capable of detecting different kind of toxic chemicals and gases, chemical warfare, radiations, and other kind of data. So now let's come further down and look in more detail on the ProRay Guardian. This is a slide just to give you a quick look and feel for the product. This is the main screen where it is showing a big area for a map. The map is where you will see your device locations, where they are deployed. And it also shows you the real-time status of your devices. If they are in alarm condition, you will see that. If they are working normally, you will see that information. If the device is at fault, low battery, you will see that. And the location really makes it very helpful to respond to those situations. And what we support in maps, we support Google Maps. So if you have internet connectivity available, you have access to Google Maps. It's free. But if internet is not an option, then you can also use Esri Maps, which we supply. It's a separate component. But in addition to that, we also support image views. That means if you have your local facility map, you can use it and customize it about your deployment of sensors and have it available here. At the lower side, there's a device list pane, which shows the real-time data coming out of sensors. You can see their status and all the sensor readings. Further below, there is a status bar, which is like a little dashboard. It shows you a quick information about the overall health of the system. If there is any alarm in the system which needs your attention, that information will be here. If there is any warning going on, that information will be here as well. On the right side, you see a system information band, where you will see all the information which is going in the system. So any activity which is happening, whether the systems are going in alarm or they are going online, offline, everything gets captured here. And you will have a very detailed audit trail available here for later use. For compliance reasons, for other analysis reasons, you can use that information. Now, let's further look at some key value features and see how those features help us in what we are talking about here, like saving lives. Real-time data monitoring for real-time decisions. We have talked about it because the data comes in real time from sensors, and it can be shared at the same time with anybody, anywhere in the world. We provide map and image overlays, as I was talking earlier. When I was showing you the screen of ProRay Guardian, you can see where the threat is because the devices will go in alarm, and you will see the device in alarm right on the map, and you can react very quickly. We have remote viewers. So if you have remote teams and you want to set up a remote control command center, you just use a remote viewer capability of the product. You don't have to have the full-fledged product installed there. You just need a remote viewer. Cascade mode, very powerful feature, which allows you to share data with multiple remote locations. And there is no like a limit out there. If you remember the example, the application example which I was talking about earlier, that uses this feature to cascade out information to remote locations. Then we have a log view, which is essentially looking at the existing data, the data which has been collected over a period of time, and do some retrospective analysis, and also use it for reporting purpose for compliance agencies. Then we also support email and text messaging so that you can get some remote alarms. And another biggest advantage which you will see, and it is a trend, becoming trend in the industry, to have an open platform. So in other words, if you have an application, existing investment in your organization, where you want to integrate our application or take the data from ProRay Guardian and import it into the system or vice versa, you can easily do that. We have an open interface documented, and you can have that integration going on very easily. Now, in terms of what you need to get started, it's something very simple. As the diagram is showing, you just need a IBM compatible PC running a Windows 7, Windows XP, or Vista. And you definitely need a network card if you want to share your data with remote locations, and your sensors. Once you have everything, you can put them together, and you have the system in place very quickly. And if Google Maps internet connectivity is available, or you want to use Google Maps, then you definitely need to use to have internet connection as well. So now that brings us to the summary, like what ProRay Guardian is all about. It's all about real-time data availability anywhere, anytime. It's about supporting compliance and reporting. It's about remote alarms, location awareness using map capabilities, then collaborating with other mutual aid companies, and then open platform. So that concludes my presentation. So I'm going to hand it over to Stephen.
Thank you so much, Jan. Thank you so much, Praveen, for presenting today's great information. I'm going to ask both Jan and Praveen to come up on stage and help us answer some questions that we've gathered all along the way. So let me pose the first question to Jan. Not sure if you mentioned this, but how do you extend the range on your wireless devices?
Okay, so the range on the wireless devices we've got several. So the ones I was focusing on were our MeshGuard products. So typically we spec it out to be 1,000 feet or 300 meters between point to point. So the beauty of a mesh network is that all the detectors can either talk to each other or they can talk directly to the controller. So to make the range further, you can either put a detector and set it up to reroute data, or we have a special device called a router, which is the same form factor as the detector, but essentially it doubles your distance. So the data will go from the detector to this router, then the router will bounce it back on to the controller. So instead of 1,000 feet, 300 meters, and then you go 2,000 feet, 600 meters, you can put another router out there and another router. So the maximum you can do is 3 routers, so that would be at 4,000 feet roughly, or 1,200 meters.
Great. Thank you for that information. And once again, just a reminder to submit your questions, please email us at events@raysystems.com or at our Twitter handle, #RaySystems. Next question is for Praveen. If a detector fails on a wireless monitor or goes out of calibration, can a remote person receive the trouble signal from the monitor?
Yes, we do have, we provide a fault alarm. That is the terminology what we use in ProRay Guardian. And if the devices are, let's say, low in battery or out of calibration, you will see that not only a reading, but you will see the location on the map as well, so that you know where to go and which device is out of calibration.
What type of trouble signals does it send? Does it have a special alarm code that goes out?
Yes, I mean, every device, I mean, this alarms are different. There are different kind of alarms. There are fault alarms, there are threat alarms. So, I mean, if it is a low battery alarm or calibration alarm, you will see a different visual, different indication, so you can easily identify it.
Excellent, great. Next question is for Jan. If I have an FMC controller on my drilling rig, how does ProRay Guardian fit in? Should both be deployed together? Or what additional benefits does PRG deliver compared to FMC on a rig?
Yes, that's a good question. The FMC controller essentially is a box with an LCD display on it. It's got internal relays. It aggregates all the wireless data directly from the detectors. So it provides a level of indication at the rig site. So you have the LCD, you've got an integrated light, integrated buzzer. So if something goes into alarm, you can clearly see it on the pad or on the drilling site. Now, where ProRay Guardian would come into play would be if you wanted to, if you needed to get that data shared with a larger area than just your drilling pad, then you would connect. There's an Ethernet connection, an Ethernet output, and a Modbus output comes standard with the FMC 2000. So you could have that data, whatever data is coming into the FMC 2000, you could put it onto a network, like Praveen discussed, and then once it's onto the network, you have a variety of options you can do with it. Remote alarm notifications on software. You can have it send emails. You can have it send text messages. You can do a slew of information, a bunch of different things with that information that comes in. But really, the reason you would use ProRay Guardian would be to send that data outside of your immediate drilling location.
Thank you for that. That's great information. Next question I have is for Praveen. How can I obtain a copy of the ProRay Guardian? Is it through an installation disk, or can I download the software?
In fact, the answer is both ways. We have this product available, the trial version, on our website. You can come to raysystem.com, go to the product section, go to ProRay Guardian, and then there's a button where you will see a request demo. And if you click on it, it will make you fill out a form. And once you fill out that information, then it will give you access to download the software. And the only reason why we collect information is so that we can send you updates in future if there are later versions available or more enhanced versions available, so that we can send that information.
That's great information. I'd love to have both options. So next question is for Jan. I've got quite a bit of questions regarding kind of collaboration and correction factors. So where can I find correction factor charts, and how do I make them accurate to the substance I'm measuring?
Okay, so we have, so correction factors, for those of the folks that don't know, you can calibrate a detector to one particular gas, and then you can have it detect for other gases. But if you want that display on the detector to show you the concentration of the new target gas, not the one you calibrated with, then there's a thing called a correction factor. So for our systems, we have for our PIDs, we have a long list of some 300 different correction factors, and I believe it's TechNote 106, which is available both on our website. That's probably the easiest way to get it, or we have a Tech and App Notebook. And then we also have another app, and I think it's TechNote 156, that has the correction factors for LEL detectors. So specific to MeshGuard, you have LEL detection capabilities. Typically, we detect for methane. You can change that. You can calibrate with other gases as well, or you can have it calibrate to methane and then target a different gas if you know what gas you're looking for.
Great. Back to ProRay Guardian. I want to try out the ProRay Guardian. Is there a trial version that I can use? And if so, how long does the trial last?
Well, the trial, as I was saying, the trial versions are available on our website, or you can send a request to us, and we can send you a CD. And the trial version will last for 4 months. So you will have enough time, and if for any reason you need more time, feel free to let us know. We can give you another copy with the extended trial version.
Cool. So Jan, this is a more general question. So I'm interested in using a wireless solution at my facilities. What's the best way for us to determine a technology solution that will fit our unique needs and our unique structures?
Okay, so I'm going to make the assumption they're talking about will the wireless work at their facility?
Correct.
Right. So one of the benefits that we didn't really talk about in the presentation is on the mesh network side, we talked about how you can have all the detectors out there, then you have your controller. We also talked about how you can use a router to extend the range of your wireless transmission distance. The other key feature of that router is that when you press the button on the router, on the display, it'll say 30%, 40%, 50%, 60%. So it'll tell you the exact wireless signal strength at that particular location. So it's really a huge benefit as a deployment tool. So before you deploy any gas detectors, you walk out there with the router, you press a button, and it tells you this location you're at 80%, which is pretty good, or this location you're at 20%. So at the 20% location, that means you probably need to deploy a router and then test it again. And so when you test it again, it should be a lot higher now that you have your router out there. So the way to figure out if it works at your facility, either if you have the equipment or if you don't have the equipment, you can call your local representative. They have demo equipment, both our Ray Systems folks and our distribution partners. They can come out, lend you a router, and then you can walk around your facility and see exactly where the signal strength comes in at the particular places you want gas detectors.
Excellent. Always like to try before I buy. So a question for Praveen. Is ProRay Guardian software available on mobile devices, such as an iPad, if I need to carry it around?
All right, the short answer for today is no. But you can always use, there are third-party applications which you can use it. You can stream the data to your mobile devices like iPad or iPhone or some other Android-based devices. But in future, you will see native application available on these mobile devices from us.
Excellent. Kind of running low on the questions now, but question for Jan. How do I find a distribution partner that is in my area and fits my business needs?
Yeah, so I believe on our website, we have the list of our regional sales managers. And I think we have it for all of the different countries, in fact, right? Not just the US. So that would be the first place to start. You're a regional manager for your region, and he can refer you to the particular distribution partners that cover your area. The other way would be to call Ray Systems, and all of our tech support and inside sales folks can point you in the right direction to one of our distribution partners or even to one of our regional sales managers.
Great, and this is the last question I have for Praveen. How does the licensing scheme work for ProRay Guardian?
All right, I was expecting that question. So the way, currently pricing or the licensing works is you need to have license for every monitor which you want to monitor through ProRay Guardian. And the licensing is subscription-based. It's a 1 year up to 10 years. So you can buy a license for 1 year for a device or up to 10 years. So of course, depending upon the number of years, you will get a discounted price. But at the same time, there are different tiers in the devices. We also support, because of different tiers, you will see a different kind of pricing. But in summary, it's a subscription-based, and it is tied up with the monitor, how many monitors you want to monitor through ProRay Guardian.
Got it. So at this moment in time, I promise this to be a 60-minute webinar, and I'm going to give everybody 5 minutes back as a present. So I would like to thank all of our attendees for taking time out of your busy schedule to join us on our webinar today. Please do not hesitate to contact your Ray Systems sales representative or our distribution partners with any questions or comments that you may have. We hope the information from this webinar is beneficial to you, and we look forward to hearing from you. Thank you for joining us today.